This is the Math Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Well, hello, everybody. Welcome back to our Math Map Book Club. It is just me today, no Leigh. But we do have Emma, who is helping us out. Well, she's kind of in charge of all of this. So if you have questions, please feel free to put those in the chat, and she will make sure that I answer those, or certainly feel free to unmute and speak up. So I'm going to open this up with a very brief prayer, just that I would speak clearly today, and this would be a time of blessing for all of us. Lord, thank you so much for gathering us together, and I just pray that that the meditations of my heart, my mind, Lord, that they'd be pleasing to you, and that as I meditated on these things, that, Lord, what I speak would be the words that you would have me speak, Lord, that they would be the words that people need to hear, to communicate clearly and be a blessing and bring you glory. In Jesus' name we pray, amen. All right, so it is the Math Map today, and we are talking about triangles and circles, which is week 16. So if this is your first time joining the Math Map Book Club, we began in January with week 1. And we went through week 15, and so we are picking up today with week 16. Leigh's vision for this time was to be preparing families sort of a semester ahead for the ideas that they were going to be examining. So that is why we are starting with 16, even though it is most likely the beginning of your academic year. We are indeed talking about triangles and circles. So we're going to start off, again, if you're new to the Math Map, one of the beautiful things about the Math Map is that we are using art and some reflections to provide a gentle introduction or invitation to the math conversation. We want everybody to really feel welcomed into that conversation. And our ultimate goal, right, is to see the truth, beauty, and goodness that reflects God in mathematics. And so as we look at some of these images, we're going to look at how can we find beauty or truth or goodness and connect that to the idea of mathematics. So our this week, I wanted us to take a look at this incredibly beautiful rose window. This one happens to be from Notre Dame Cathedral of Strasbourg. We know that there's a lot of these rose windows. When I was in England last month, I had the opportunity to go to the York Minster, where they had some beautiful rose windows and stained glass. And it is something to see in person. But let's take a look at this image that's here on the screen and our lesson title, which is Triangles and Circles. And what are some things that you might see? So feel free to unmute and just share your thoughts on this piece of artwork. Why would we have chosen it? What does it tell you about mathematics or spiritual truth?
Well, it kind of looks like an eye. I know we're talking about, triangles and circles, and I certainly see those things, but with the black background, and then that outer part that has the black and just the gold or the brown, or the red or the brown, and then the inner part, it reminds me of an eye with the colored iris and the pupil in the middle and things.
Yeah,
I like it.
I was just love the pattern that's repeated over and over, just the color pattern and the shape pattern, and it's very restful. Like it's there's a unity in all the different patterns, but that I love that continuity that it brings it together.
I see the symmetry in it.
It's really awesome to me, all the different varieties of things you can create with very basic shapes.
It also just reminds me how all these pieces individually are beautiful, but when you put them together with design, because God is a design, right? That they create something beautiful. So if you isolate one, it's different. There's so beauty in that one piece, but together they make something very grand.
So those are some great things there that, again, just for those of you who may be new to the math map, one of the neat things is that this is a conversation you can repeat every year for many years, talking about this piece of art. And so when we think of triangles and circles, we may just start off by talking about how there's individual pieces that make up a greater whole, right? So that even though there may be these individual triangles that we can see, that when they're put together, we see this circle, right? Even though there may not actually be, it may not actually be a full circle that we're seeing, we understand it to be a circle, right? That whole that we're aiming for. As we get into over the years, talking about triangles and circles and talking about what that means and the trigonometry that represents, right? We might talk about the idea of patterns and repetition, because that's one thing that we see with our trigonometric functions, is this idea of repetition and pattern that happens in them. And then ultimately, where we were talking about how, we can take these basic pieces and make something more complex. We can take these trig functions and use them to approximate like all these crazy functions that exist out there. So there's a lot of ideas that we can build from this, but we can also just go back and, as Angela said, like, it looks like an eye, right? Oh, it's really pretty, but gosh, it looks like an eye. What does that, and maybe that connects to, for a student who's reading The Hobbit, right, in the Eye of Sauron, maybe we make some connections there. So we can really enjoy talking about our art. So each week we review this idea that mathematics is a language. One of the things that we've been talking about a little bit more as we've been talking through the math map is the idea of the trivium, right? Really being about the skills of learning and also literature-based skills, right? So when we think of this trivium, a lot of what we're building are literature-based skills, and we're preparing for that quadrivium where we're looking at the math. So there's a lot of the quadrivium ideas when we talk about the math map, obviously, because we're talking about arithmetic and we're talking about geometry and all kinds of things. But we're also really stressing the importance of learning the language of mathematics. And so when we're talking about the language of mathematics, one of the things that we can do is we can describe concepts that need that hospitable invitation, right? So in a minute, I've got that word trigonometry up on the screen. And for people that I've talked to over the years, trigonometry may be one of the most triggering words that they hear. And we'll talk about why that is. But when we came up with our weekly topics, and we came up with this idea of week 16, and we're going to be talking about triangles and circles and really trigonometry, Leigh really emphasized that she didn't want people to see words and go, oh, that was hard. She wanted to use hospitable language. And so as you look at the math map and become familiar with the math map, you're going to notice that there are some weeks where we're using language specifically to provide a hospitable invitation to that topic. I don't know why, but we're just pausing to digest that until the computer deems the next slide is ready for us. There we go. So just to help you see where we are in 2D. So notice if you look above week 16, week 15 was assessment, and that's where we talked about our blue book. That would have been the conclusion of our first semester. So our second semester is picking up at week 16, but we're still in 2D. So even though our students are coming back into a challenging concept after the break, they're coming back into the same dimension. So we're coming back into somewhere that is familiar as we start our second semester, even though we're coming back into one of the topics that may be one of the more challenging topics that we'll look at this year and every year. And that is the topic of trigonometry. So feel free, raise your hand if you have really happy memories of trigonometry from high school. Right? I see lots of people are like, yes, that was my favorite. Unfortunately, over the years, as I've talked to people, this is probably one of the places where I think we have let people down. And it's because of the way modern curricula work. That modern curricula, right, segment things, and they say, okay, well, here's your time. This is the time where we're going to do trig. And I was a classroom teacher. I was a high school classroom teacher for several years. And so I can speak from experience that when you got to the portion of the book where it was time to talk about trigonometry, right, that usually what happened was on Monday, you said, this is sine, cosine, and tangent. And by Tuesday or Wednesday, you were solving word problems using sine, cosine, and tangent, and you still didn't really know what those words meant. So we took grammar, right? Just your memorization, your grammar work, the things you needed to memorize. And we basically said, okay, memorize this and use it all at the same time. And I think most of us that are on the call are classical educators. And we know that that doesn't work well, right? It doesn't work well when we're talking about academics. It doesn't work well when we're talking about something else that we're doing, right? If we're learning how to crochet, right? Right, if I'm trying to learn just what it means to do a single crochet or a double crochet or a half double crochet, and I'm connecting that now to the idea of the stitches. Well, if I try to do that all at the same time that I'm following a pattern, right? I'm constantly going back. Wait, what was that half double crochet? What was that? I'm constantly going back and referring to what were these words at the same time I'm trying to follow a pattern. Whereas if I just took some time and I practiced those stitches and practiced those stitches and practiced those stitches for a while until I got really comfortable with what they were, then when I follow the pattern, it's a lot easier, right? So that's that idea of a classical model, which is what we do for most things other than education in our modern world. So as we're reclaiming mathematics classically, right, we want to think about the fact that first we're going to look at the grammar, right? So by introducing trigonometry, triangles and circles, to our youngest students, we're going to give them the opportunity to become familiar with that language, to memorize it without any understanding, right? To memorize it. And then over years, they're going to practice it. And then eventually, they're going to reach that place of understanding. But unlike a modern curriculum where we think, oh, we're going to memorize this and use it all in 1 week, we're going to do this over many years. So I think this is one of the greatest examples of the power of the math map and looking at math classically, is that we're giving our students time to really memorize that grammar, to develop the memoria that then they're going to be able to use down the line. So the very basic grammar of trigonometry is that it's one, they're ratios. And so that's what we're talking about. There are ratios between the sides of triangles. So if it's a ratio, it's a fraction. So notice there's a lot of grammar here that I need to help my students unpack over time, not all in 1 year, right? So when I think of trigonometric, I can help them recognize that right, is a triangle, right? Metric, we're measuring. So these are ways of measuring triangles. Going back and reminding them that a ratio is something that can be written as a fraction, right? So as we look at these things, we see fractions. So right there, if we help them to unpack what those two words mean, trigonometric ratios, we're going to help them to see we're doing things with triangles and we're looking at ratios. They are ratios of sides, and they depend on the angle, right? So depending on how big or small my angle is, the ratio between those sides is going to change. So I won't get into the why all of that works, although I think it's really fun. I really want to just focus on the fact that if your student is new, or if you are revisiting trigonometry, the first thing you need to do is just put the time in to memorizing what these ratios are, right? And that's what in modern education we don't often do. So normally there would have been a slide there for an ad, and I missed that slide because I wasn't sure what Leigh was advertising. So I'm just going to take a moment to encourage you, if you haven't found these materials on CC Connected. We do actually have a new document this year to make it easier to access these materials. When you first log into the Learning Center, you should see an option to click on sort of a welcome to the math map that is a 2-page document. The second page has a bunch of links so that you can just click on those links and it will take you to all of the elements that are available in the math map beta. And so you don't have to sort of scroll through on CC Connected. So if you haven't found that, if you are using the Naturals beta materials and haven't found that yet, I really would encourage you to go ahead and use that. So practice time. So first, I just thought I would ask 2 questions for you. One is going to be maybe easier than the other, but when we talk about our week, the title of our week, triangles and circles, why do you think that's our title? Why triangles?
Because you can divide up the circle in triangles.
Okay, so we're talking about triangles, right? The trigonometry and triangle measure, right? So we're talking about triangles when we talk about trigonometry, and then somebody said, because I can put them in circles. And so I just want to point out the image over here. Let me just choose my laser pointer. So if you look up here, right? If I keep going around and around my circle, right? What happens is I keep going around. So you can look at some of these different triangles that I'm creating. But if I go around my circle and then I start to go around again, what happens?
– I'm not sure I understand
Yeah,
what
Okay.
you mean. Do you mean how we would measure it, or that it's unwinding, or that we could get dizzy?
We can get dizzy, right? So yes, you could get dizzy. So think about, well, if I said I wanted to go around 1/8 of a circle, right? And I get to here, 45 degrees. Well, if I go around and I get to, and let's say I go 1 1/8 times around, do I get to the same point? And if I went 2 1/8 times around, I get to the same point. So what happens if I kept on going? Would I keep hitting that same point over and over again?
Yes, there's overlap and you repeat the pattern.
I keep repeating that pattern. And so that's one of the reasons why this idea of circular, right? When we think of circular reasoning, we think of that idea of going around and around. Somebody said, right, we're going to get dizzy, right? Because you keep going around and things keep repeating, right? And so that's the whole idea of circular reasoning, right? Is, well, I just keep repeating the same thing. I never get back to a starting point. Well, this image here, right? When I look at my angles on the circle, they just keep repeating. But if I was to translate those into, right, how many times I went around, I can have more than 360 degrees. And that gives me this picture here, right? And so this shows me I could keep going on this way and I can keep going the other way. And what I end up with is being able to examine all of those angle values to infinity, right? Depending on how many times they go around the circle. When I unwind that, somebody used that term unwinding. If I could unwind that, right, and look at it on this kind of a graph, then I start to see that those values all repeat over and over again. And that's a key idea behind trigonometry, is that these values repeat over and over again. And because anytime I want to then use math to model something that's happening in the real world, so think for a minute, what are some things in the real world that happen in cycles?
So can I actually ask a question?
Sure.
Kirsty, I just want to make sure I'm understanding. So are you saying that the number line that has the sine wave on it, that the line represents the perimeter of the circle kind of spread out in both directions?
Not really, no.
Okay.
It's more, if I could say, okay, if I went and said, I'm going to find, right, the first time around, I go around and I'm finding all of these different angles. And so it's not really the circumference, it's the angle measure. That angle measure is now my horizontal axis.
The central angle measure.
This angle measure, yeah. So for this one, it would be 45 degrees, right? Which would be right here, 45 degrees. Then I'm saying, okay, well, that angle measure, what is, in this case, I'm just looking at the sine of the angle. I'm just looking at the sine of the angle. So it's really how high or low is it? What's its place on the vertical axis? And so I'm going to plot that. So I can see here, I've gone 45 degrees, right? 45 degrees. And I'm at the square root of 2 over 2.
That's a
And so
distance or a length? No, I think I'm not quite following. I'm sorry.
Well, no, it's okay. It's the ratio between, it's the ratio of the opposite side and the hypotenuse in this case. So, and it's my coordinate on the y-axis.
Okay, so you took so the sine wave is those ratios, the
Yes.
values of the ratios on a graph,
Yes,
all the way around the circle.
yes.
Okay, my head just exploded a little. Okay, I have to think about that for a little bit. Thank you.
No, that's okay. And it is, because we don't oftentimes help people to see, right, how these two ideas go together. But we're aiming to, right?
Okay.
And we're throwing a lot at you in one 45-minute book club. So back to my question. So you're getting that idea, right? This idea of going around the circle, and now I'm doing this along here, and it's going to repeat. So what kind of natural phenomena or real world examples are there of things that repeat?
Sunrise and sunset.
Sunrise and sunset.
And the 4 seasons.
The seasons.
Is time the way we have it calculated?
Okay, although time doesn't tend to go back and forth. I tend to think of time as like marching on. But if we think of maybe the day, right, day and night, those kinds of patterns that happen in time. We just took Kate to college in Palm Beach. What happens at the beach every day?
Mhm.
The
Tide.
waves,
Waves.
Waves,
Tides.
tides,
Mhm.
tide.
The cycle of the moon.
right? So lots of things. Hopefully nobody has ever stuck their finger in a socket, right? But when we plug something in and we're told it's an AC outlet, that's alternating current. That's exactly what is happening, right? The current is going in waves, it's alternating. So all of these things, electricity, light, right? Our homeschool day might cycle, right? We might do the same things every day. So lots of things that change in time, right, are cyclical, right? We think of them as being cyclical. And that's something that God established right at the beginning, right? When we talk about cycles and that cyclical nature of life, right at the beginning of the Bible, God says, right, that there will be seasons, right? That we're going to operate in these seasons, the cyclical nature of life. And when we want to represent that cyclical nature of things, and we want to represent that mathematically, this is what we oftentimes come back to. We come back to the sine curve. And even if we have to sort of adjust it a little bit, right, we can transform it to be not just this picture, but it's the basis for all of these things that we want to represent that change in time, that are cyclical. So this fundamental idea of cyclicalness that God says, right, seasons, and things are gonna operate according to seasons, right? If we want to understand what that means, right, he gives us this picture in mathematics of the sine curve, to help us understand what that means. What does that look like? Right? So thinking of that, right, thinking about what does that look like? When you look at this curve, does it ever go above 1? Or below -1?
No.
So there's some boundaries, aren't there? What does that talk about when we think about God and, right, the cycles of life? Do we sometimes feel like things are out of control? Have you ever felt that? Right? Where we start to imagine, like, right, we're dropping our child off at college and all the possible things that can happen. But what does God, right? He shows us with the sine curve, he's put boundaries, right? Things can only go so far, right? In either direction, right? He's giving us this picture that when we operate in seasons, right? When we operate in seasons, we're always coming back, right, to the center in some way, right? That there's these guides that he's providing, right? So for me, that's just a comfort today to think that he is saying you can only go so far. And that mirrors his words in Job, right? He says to the waves, you can only come to the seas, you can only come this far. Right? And we see this echoed here in the sine curve. Right? So that's not really math practice. So let's do some math practice. So we're going to just talk about the sine ratio today. So I won't put anybody on the spot to see if you memorized it. I'm just going to go ahead and write this on our screen so that we can all remember. I just have to turn. There we go. Turn to the pen. All right, so I'm going to remind us that need to change color. So the sine, we abbreviate it SIN, right? But it still said sine. And we can use X or we can use theta. So I'm going to go ahead and use theta today because that's a very common variable for an angle. The sine of an angle is the ratio. So ratio tells me it's a fraction of the leg opposite. And we're going to look at that. And now look at this right triangle we have on the screen. And I'm going to say that this is theta. This is my angle. So when there's a lot of grammar here that we would have built up to. So when we're talking about a right triangle, the sides of a right triangle have specific names. The long side is the hypotenuse. And it's always going to be opposite the right angle. The other two sides are called legs. And so my ratio says it's the leg opposite. And so I'm going to look for what's opposite my angle. And this is going to be the leg opposite the angle. And although we're just looking at sine, this would be my leg adjacent. And I would need that if we were doing cosine. Okay. So I've labeled my triangle, right? So here's where language is so important, because knowing how to label my triangle is the first step to being able to determine what the ratios of the sides are. So my sine is my leg opposite, and it's the ratio of that to the hypotenuse. Okay, so that's my sine. So now I'm going to give you, we're going to put some numbers in. And this is 3, this is 4, this is 5. And I'm going to say, okay, what is the sine of my angle? I don't know what this one is, so I'm just going to say it's theta. But I can, even though I don't know what the measure of my angle is, I can still calculate what my sine is. So go ahead and take a minute and write that ratio down. The ratio of the leg opposite to the hypotenuse. And then is there anybody who wants to speak up and say what that would be?
4/5.
4/5. Now, here's a great example that where seeing that ratio is 4/5 tells me some things visually, right? That my leg opposite is some multiple of 4 and the same multiple of 5 for my hypotenuse if it wasn't 4 and 5, right? If I had picked something else. A lot of times, if you use a calculator, it's not going to give you 4/5. What might it give you instead?
0.8 or 0.8.
Yes, so right, it might give me 0.8, which is the same numerically, but we lose that geography, right? We lose the sense of what that 0.8 means when we see it written that way. So here's a great reason why we we in the math map continually go back to saying being able to write numbers in all of its forms. Right. So being able to write 4 over 5 as a fraction and 0.8 and being able to recognize that they are the same thing. Right. So it's really important to build those skills with our young students because, and again, going back to our conversation about modern education and how I taught this, right? Because you're just going through a textbook, right? This is a stumbling block for students, right? If they use their calculator or even if they look it up in the back of the book and they see that it's 0.8 and it no longer looks like a ratio to them, right? It becomes a stumbling block and it becomes harder than it needs to be to make the connection. So let's go ahead and do something else. Just to make my point here about that one, I'm going to give you 9, 12, and not 15. Yes, 15. Okay. So what would be the sign of the angle now?
It can still be 4/5
And why is that, Babs?
because it's 12/15 and you can reduce it.
Excellent. So Babs just said, look, I can, even though now it doesn't look like it on the screen, I'm looking at a bigger triangle. I haven't actually changed the angle. And so the ratio between the sides is still 4/5. So again, here's where those arithmetic skills become so important for students, right? That understanding that 12/5 and 4/5 is the same thing, right? These arithmetic skills are really important for us to encourage our students to build over years, right? So while they're also working on the grammar and they're memorizing what sine means, they're memorizing what cosine means, they're memorizing what leg and hypotenuse mean, we're really emphasizing those arithmetic skills at the same time so that when they encounter the sine of theta being 12/15, they can recognize that that's the same as 4/5. All right, let's go ahead and do one more or maybe 2 more. So take a minute and write down the sign. And then I have a challenge for you to look at that triangle and see if you recognize what theta might equal. So I'm still talking about a ratio. It's still going to be a fraction. And so anybody want to shout out what they have for the sine of theta? Crystal, I saw your lips moving, but you're muted, right? So the square root of 2, that's my leg opposite, over 2, that's my hypotenuse.
Yeah.
Now, a lot of you, depending on how you grew up, may be very tempted to take that and convert that to its decimal approximation, but you don't have to, right? Because we really want exact answers. So unless you're going to go and buy carpet or something where I need, right, a decimal approximation, I can just leave this as the square root of 2 over 2, right? Now, does anybody notice on our triangle, in this case, we have both legs are the square root of 2. So if I have both of my legs are congruent and have equal measure, does anybody remember what we call that kind of a triangle?
Isosceles.
Isosceles. So if the legs, the sides of my isosceles triangles have equal length, then my angles have to be equal, which means that my angle is going to be worth how much? What's theta?
45 degrees.
45 degrees. So this highlights another thing in the math map, and you can sort of see it over here underneath. We kind of have it that we're going to have students memorize, right, the ratios for key angles, right? So 45 degrees is a common angle, right, because it's an isosceles right triangle. So it's special. So we call that our special right triangle, or one of our special right triangles. And so as we memorize these values, right, we're building that memoria of how those values are going to change as we move around the circle. Right? So we're going to really encourage students to be memorizing these tables so that when they see the square root of 2/2, they're going to go, oh, well, that's a 45-degree angle, right? I can automatically know that and build that memoria. So that's just a little bit. That's just sine today, as from our week 16. As we talk about triangles, we're talking about right triangles and the ratios between the sides. We're looking at them in the unit circle because that helps us to see how they are cyclical in nature and how that cycle builds. And then we use that to really model all kinds of things in our world that God established to work in cyclical patterns, right back at the beginning. And our last slide is coming up is a thank you. So as we wait for PowerPoint to load that last slide, does anybody have any questions or things they'd like to share? Those of you who were with us in the spring, anybody have anything from the summer that you're like, oh, this happened this summer, and I would love to share how I saw math in the world around me. That's our goal, right? Our goal is to see the unseen. And so as you guys go forth today and are excited about coming back next week for intersected shapes, I really want you to look, right, to see the unseen. And so that might be the unseen math, right? That as you look at the world around you, you might suddenly look out the window and go, wow, all of those pine trees, they're parallel to one another. That's amazing. I'd never thought about that before. Or it may be that because of math, right, you're making that spiritual connection like we did today, going, that God has established these boundaries, right? Through the use of cyclical patterns, he said, this is how far you can go. And so we can trust him. So I want you to be encouraged this week to look for the unseen, right? In the world around you and the work that you're doing to really look and go, okay, what is it that God is revealing himself to me, especially through mathematics? And I will see you back next week with Leigh as we talk